Hello, welcome to another Random Code stream. This is Advent of Code 2025 Part 7. And before I continue on, I got to do two things per tradition. I got to get my music going. And then I also need to pour some coffee. In my bag, was this carafe? Pot? Warmed pot? I don't know. It's got coffee in it. So that's all that matters. When I used to have to drive to work, I'd have this big thermos that would hold a ton of coffee, and that thing pretty much, it would keep something warm for like 2 days. I'm going to move over here to my screen showing everything. But yeah, that thing was amazing. I used that once. I made some coffee. It was my older kid and I, and they were part of this mountain biking team, and they would do this thing in the summer up north in Minnesota to do tracks. And I was like, I gotta have my coffee, but we were camped out somewhere, so I made some coffee, put it in that, and that stayed warm like for at least a day, if not 2. That was amazing. Anyway, all right, so state of affairs. Day 10 is, I think it's something called a directed graph. Because if you look at this, you're basically creating numbers. So this, if you think of these as bits, they're on and off. Do you want to get from 0 to the number you're shown here? In this case, that's 3. I think. Or I think the least significant bit is here, so it'd still be 3 either way. This one would matter, and this one, it would matter too. But the point is, you're trying to move from some 0 state to a final state of some number. And each of these takes you, like if you apply this to 0, then it does something. And then that goes from 0 to whatever that number would be. This one would flip the bits such that it would go from 0 to this number, and so on. And so then at each point, though, you could apply all these again, except applying the same one twice doesn't make sense because that just brings you back to 0. Right? So there are some paths that don't help because they don't get you to where you want to go. But the whole point of it is, I have no clue on how to solve this. So I'm skipping over this one. I do think I have now a solution for not only part 2 of day 7, but also 9. 9 would be kind of brute force, but I think I've figured that out. So if I go back to 9, you see here that basically what it's saying is, could I make, if I go to part 2, I could make a rectangle out of this, okay, because that works. But if we go back up to the original problem, I could, that's the right thing. No, I could. No, I couldn't. Okay, maybe I don't have it solved. Yeah, so the whole point is you can only make rectangles that are within the area of the shape. So I was thinking of it wrong. So I don't have a solution to this. You basically what's saying is you can't take this one here and this one and make that, because now you're going outside of the area. So you have to know which points are within and which points are without. So you can't go outside. And so I messed that up. The solution I thought I had, it would not work because it would be completely wrong. You can only stay within the area. So we're going to move on, though. We're going to move on to 11 and then 12 and then back to 7. Because, again, I think I have a solution for 7. I don't have one for 9. I don't know what to do for 10. So that might take some research to figure that one out. But is what it is. Let's go to 11. Let's see what it is. Reactor. You hear some loud beeping coming from a hatch in the floor of the factory, so you decide to check it out. Inside, you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping, a large reactor which powers the factory above. Some elves here are hurriedly running between the reactor and a nearby server rack, apparently trying to fix something. One of the elves notices you and rushes over. It's a good thing you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. You glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs, your puzzle input. For example, bleh, nah. And that. Okay. Each line gives the name of a device followed by a list of devices to which its outputs are attached. So BDE means that the device the has two outputs, one leading to device this and one leading to device this. The elves are pretty sure that the issue isn't due to any specific device, but rather that the issue is triggered by data flowing from some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. After dividing up the work, the elves would like you to focus on the devices starting with the one next to you. An elf hastily attaches a label which just says you, and ending with the main output to the reactor, which is the device with the label out. To help the elves figure out which path is causing the issue, they need you to find every path from you to out. An example, these are all the paths from you to out. Data could take the connection from you to B, then B to D, D to G, and then G to out. B to E to out. C. It's another freaking graph problem. Devices starting with the one next and ending with the main. Which path? You need you to find every path from you to out. Right. U is BB, U, B, and C. B goes to D and E, C goes to D, E, and F. D goes to G, G goes to out. E goes to out. F goes to out. How do you know which ones are different? Do you have to... Oh, God, another graph problem. A, though, goes from U to H. I'm sorry, A goes to U and H. What confuses me again is the way this problem is worded. Data could take the connection to B then to E, then to out. The way that this is, again, the way that this is worded, if there's one thing, and it's just the personal gripe, the way that the problems are worded in Advent.Code sometimes are not done really well, and they're not shown really well. Having a picture here would do wonders to explaining what you're getting at, right? Because this one's saying U to B. And we don't care about this one. All we care about is starting at U. Where can we go from there? And so this again is just, you have U that can go from one to many, that can go to many. I'm assuming there is no cyclic. It says it can't flow backwards. I'm assuming that the devices and outputs don't ever get you into a cycle. I could be wrong about that, but I think what you could do is you could simply just follow the flow from U. Like you parse the input and you say for each node, where could it go? And so you have the key is the node, the values are a list of other nodes that are the next direction. And so we start with the node that starts with U and then say, okay, go to the next one. Well, that's B. So where does B go? And as you're doing each one, again, you create a string that gives you a unique path going through. And as you go through each one, when you get to an out, you stop. So it's going to be a recursive function, but whatever. I think I get this one. Let's get the input, which is probably going to be massive. Yeah, I mean, you start having something like this that just gives you a whole huge set of possibilities, but again, without knowing graphs and not knowing how you can minimize paths, and where you can go. But we're not trying to minimizing. We have to literally find every path. So we don't have a choice. We've got to go through every single one. So again, maybe I'm missing a faster, easier way to do this, but I don't know. All right, so let's do, this is 11. So we never did 10. No, we did do 10. Well, we didn't do 10. We put the data in, the files for 10, but we actually never finished it. Okay, so we have our input. Let me grab this and get the file. Yeah, that could get quite large, but what are you gonna do? How many paths could you get? Oh, huge number. I don't know. So what do they call this? We'll just leave it as data. Okay, so first of all, we got to parse this. And what we're going to do this is we're going to call them connections. And that's going to be a new dictionary of a string with a list of strings. Okay? So we're going to say for each. Now we're going to say var parts. We're going to say connection.split. You're not really helping, because it's a colon, okay? Now the left part is the key. The right part, we still have to split more. So what we want to do is we want to say var outputs is equal to parts of 1. And we're going to assume there's always 2. We want to trim this now, okay? Because we want to make sure that we've trimmed off any leading and ending white space. And now we want to split it on a space. Okay. So now what we can do is we can say connections at parts 0 is equal to a new list of strings based on outputs. Or that. So that parses it, right? That's the first part. Now becomes the harder part, because we gotta say start at no. No. Okay. We're going to start at 0, or U. Connection at U. And then we're going to say for each var destination node in U outputs. Okay. What we want to do then is say, take that one, add it to our current input, our current, where we started from. And then say for each of those, where do we go? Unless we hit an out. So how do we want to code that? I'm assuming that you would, and this may be a bad assumption, I'm assuming that you would actually not ever find either a cyclical path or a duplicate path. So how do you count this? If you, I mean, I know it's going to have to be recursive. If that equals out, then path count plus plus, because we found another path. Else, we need to basically do this. And so we need to get the next set and say, did we we could have a local function that takes a reference to the connections and then also a ref on the count. So every time we go through it, if we hit the end, we just simply increment the counter. So static void examine outputs, and that'd be a list of string outputs. Actually, what we could say is string input. That's where you start. we take this, and we could actually alias this to say connections. Ref ulong path count. And so then here we would say examine outputs, giving the string of u connections ref path count. We'll do that, and then we just return it. So now in the function here, we're going to say the outputs are based on the connections of the inputs of the input. And so outputs, output. If that output, is out, then we update the path count. Otherwise, we have to say examine the outputs, where the input now is our output that we're looking at, connections ref path count. Now again, this is making some assumptions here. I'm assuming that the paths that we're going through are always going to be unique. We're never going to hit a one, we're never going to hit anything that's cyclical. And two, we're never going to get duplicates. And those could be very invalid assumptions, but that's what I'm going to go with right now. So if we do a test, on that, 11, 11, let's take our puzzle input and say 11, run that, and they're saying that there should be 5. Well, it passed. We did get the right answer, but the actual solution is much bigger, the input. So we're on day 11 because we skipped. We skipped 10 entirely. This might take a while. But let's see what it does. That was way too quick. That was way too fast. This is wrong. There's no way. I simply refuse to believe that that's correct. Okay. That's surprising. I didn't think it was going to be that simple. And it's fast. Okay. Sometimes I got to kiss myself. Okay. So sometimes you got to take those wins. You got to take those wins. Part 1 of day 11 is done. Okay. Enough celebrating, because I got the feeling part 2 is just going to absolutely destroy me. So I'm shocked that I actually got the... That just came quicker than the answer came a lot faster than I expected. Okay, I'll take a victory. What's part 2? Thanks in part 2 your analysis, the elves has figured out a little bit about the issue. They now know that the problematic data path passes through both DAC and FIT. Fast Fourier, yeah. I know all about fast Fourier transforms. Well, I used to. God, I had to take a signal processing course when I was a junior. That one, oh, that almost wrecked me. Just did not get it at all. Ironically, my master's thesis is on something that's called a number theoretic transform, which is similar to fast Fourier transform, except it's all in modular integer ring arithmetic. It's the same thing as an FFT, but it uses all integers. Someday I want to go back and revisit that and get my code that's written in C into a repository just so that I have that code for my own historical purposes, because I don't. The code is in my master's thesis document, but I never saved the actual C file. And that code is horrible. I've always had the idea of taking that code, getting it into a state where it actually gives me the result that I expected it to, and then seeing how I could update it for 2026 or whatever in C#. So take the code that it's in C, but move it into C#, but do as faithful of a one-to-one transform as possible, and then go nuts with trying to optimize it. Anyway, they're still not sure which specific path is the problem, and so now they need you to find every path from SVR to out. However, the paths you find must all also visit both DAC and EFT. FIT. In any order. For example, this new list of devices contains many paths from SVR to out. Okay. However, only 2 paths from server to out visit both DAC and FIT. Find all the paths that lead to server to out. How many of those paths visit both DAC and FIT? Okay. So now what we want to do is part 2. So we can kind of take what we got except a little bit expanded, I think. We want to start at SVR. Okay. And as we examine all of these outputs, what we want to carry through is the input on this path that we're examining either a DAC or a FIT, and then we track that through as we go along with this, right? And so that way we know by the time we get to out, have those 2 flags been set for the path that we're looking at. And if it is, then we update this. So we could have a bool visited, DAC visited, and a bool FIT visited. Visitations. Okay. And so we come into here and we're going to say visitations dot is equal to the input. Whoops, I'm sorry, is equal to the input equaling DAC. Well, get your... There. Now, if the output is out and visitations.doc and visitations.this. Sorry, I just had a message come through. We're getting a lot of snow here today, I think. Huh. I thought that was an important message. It wasn't. Okay, so if it's out, so let's do this. We don't want to continue on because we are done here. The thing we want to check, though, is the count. That's important. We have to do that in 2 steps. Otherwise, we're going to say take that output, pass in visitations, and the connection, and the path count. And so when we look at the next node, we're going to update those 2 flags for that next call. Or equals. That would be important. Because we could have had it on, we could have found it, and then we find the next one isn't it, but we don't care. Once that flag is flipped, we keep it on. So now we have a different input here. We can say false, false as a starting condition. And I believe tuples are value types. Because we do not want to keep passing this by reference. Well, I guess we could. But we do want for every path that we go down, we want a new instance of this with the same previous values. And that's a trivia question for C#. Are tuples value types or reference types? I forget. What did they land on? Because a tuple type are tuples in C# value or reference types? Value tuples. Yeah, so they made a system. That's right. They made a system tuple. C# tuples, which are backed by system value tuple types. Yes, so they will copy every time. Okay, I remember they made tuples and then they made the tuple type in C# and they made them value tuples. That's the actual type in the background. Okay, so I think that works the way we want it to. It makes a copy of it, but I think that's kind of what we're looking for. Well, let's see. Part 2 is going to be slightly different. Input. We want to go here. Part 2. And they're saying there's 2 paths. Now let's check some. I want to just check this again. So we start SVR, right? SVR, and then we're looking for DAC and FIT. In any order. And it doesn't say they couldn't do it more than once, though I think that would lead to a circular condition, so I think it would be exactly once. I think. So, does this work? It does. What about 2? that suddenly becomes much slower. That's interesting. Because the only thing we're passing through all the time is just this extra little struct to say, did you hit that? Or in this data file, they do have something in there that says that there is like a cyclic thing. I'm actually kind of surprised that it's taking this long. That's my gut reaction. The only thing I can think of is that it's spinning. Because the only thing we're tracking now in the 11 solution is this thing. Did we visit these nodes? But it's the same code as before. There's no difference between the two. I am really shocked that this is taking as long as it is. The only thing I can think of is that there is kind of some circular thing in this case that makes you... Yeah, and that's only in there once, so nothing else leads to it. Huh. Okay, I admit, this one is surprising. We have like what? 588. The only thing I can think of is that that's the starting node for the part 1 right there. But other ones could get you to U. And those might be... Hey, cruising. Those might be part of the server one, and so there's just a lot more paths to it. The problem is that I don't know... Because I'm not bothering to keep track of the path itself, right? I'm just... I could show it as I'm doing this. Because I could print console right, not right line. Once I get to out, then I print console right line to show what I'm doing. Yeah, I don't know what is up with this. Because we are going... server to out. Yeah, and in both cases... we're just checking to see, did you hit out? Where you started is determined by what you're inputting as. So I'm kind of curious. If I did this and I said console.write, the input, okay? And we probably want to do like the input with a space there just to make it neater. And if we hit out, we could do console.writeLine out. I think that would write in the current line and then go to the next line. I'm kind of curious what this does. Not what I expected. Well, true. Okay, that doesn't quite work because as you're going down the paths, you hit an out, you're going to say write it, but then you're coming up back to the previous one, and that might have been a path of that. So that really doesn't, this really doesn't help. Yeah, I'm not sure what's happening here. Let's take this up because that's not really giving us any real insight. The paths you find must also visit. Yeah. Our first one, the first problem must not have had as many paths. Server must have a lot more paths. And it's just taking a long time to get to the answer is my thought. I think you get to the out real quick. But I don't think, again, I don't think there are any cyclical paths. I don't think there are any, each of these server to the next to the next to the out is, you'll eventually come back through all of them. You'll come back up. Right? So I'm going to go move to the next one. I feel like I might run this over lunch and just see what the answer is. Because again, there's no other way to solve this as far as I know other than to just say, here's my input, here are my outputs, and just keep following and keep track of, did you hit an FFT and a DAC along the way? There's just potentially a lot more paths with the server start than there is with the U start. That's my only guess. I just hope that we're not hitting a case where we're looping. Though I think we would have hit a Stack Overflow case, and if that was happening. Because if we hit something where you do like B goes to C and then C goes to D, D goes to B, you do B, C, D, you keep going through that examine outputs call recursively until you blew the stack. And that I think would show up rather quickly. And the visitation should have no impact on the search. Again, I think this is just a case where the search starting with SVR is much longer than the search with U. I guess maybe one optimization you could say is, well, only start at actually DAC. Yeah, but you need to know you started at SVR with that. It's possible that if you have a path with DAC in it, it didn't start with SVR. It didn't start with the server. It could have started somewhere else. So you need to make sure that you're actually starting from SVR. Okay, we're gonna skip part 2. I don't think this is wrong. I don't know why it's just taking forever. The answer is not clear to me. So I'm going to let my brain stew on that. Again, this is something that I try to emphasize not only with myself but with other people. It's if you're sweating over a problem, if you're sweating over something you don't understand, and I know this day and age it's like, ask Copilot, ask Claude, well, that could help. That's not saying that kind of question and answer. Again, to me, that is the same thing as, in some ways, you could arguably say it's a better, or if it gives you bad output, worse. But it's the same thing as like when you're talking to the teddy bear, or you talk the problem out to somebody and saying, this is what I'm having as an issue. Doing it with somebody else, arguably even doing it with an LLM, is somewhat helpful because you're going to get a different set of eyes, a different set of views on what you're running into. Or if you just talk it out to nobody, just the pure act of talking out what the problem is may trigger something in your head to go, this is actually what I'm missing. And sometimes just walking away from a problem is the right thing to do. Sometimes it's just best to go, nope, I'm just going to walk away. I'm going to do something else and try to do something else. And then in that act of not thinking about it, you end up thinking about it anyway. And you start coming up with potential, solutions. So we're going to move off from this one. I will come back to it. I'm probably going to run it over lunch and see what happens. Let's go to 12. Okay. Day 12. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. Just like Die Hard or Aliens. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents from all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follow a standardized two-dimensional unit grid. You also can't stack presents. The circle goes in the circle hole. As always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of the present shapes. Second, it contains the size of the region under each tree and a list of the number of presents of each shape that need to fit in that region. What? The first section lists the standard present shapes. For convenience, each shape starts with its index and a colon. Then the shape is displayed visually, where a pound is part of the shape and X is not. Okay, so this is like a C, this is like an I. I wonder if this is good to spell Merry Christmas. The second section lists the regions under the tree. Each line starts with the width and length of the region. 12 by 5 means the region is 12 units wide and 5 units long. The rest of the line describes the presents that need to fit into that region by listing the quantity of each shape of present. Is it 1, 0, 1, 0, 3, 2 means you need to fit one present with shape index 0, no presents with shape index 1, one present with shape index 2, no presents with shape index 3, 3 with 4, and 2 with 5. Presents can be rotated and flipped as... I don't want to play Tetris. To make them fit into the available space, but they have to always be placed perfectly on the grid. Shapes can't overlap. That is from two different Oh god, this is gonna suck. The elves need to know how many of the regions can fit the presents listed. In the above example, there are 6 unique present shapes and 3 regions that need checking. The first region... I have no clue how you would solve this in a short amount of time. I am completely lost. I mean, I get the problem. I understand what they're saying the problem is. Trying to do that programmatically, I have no clue. None off the top of my head. You know, and if you look at the puzzle input, it's probably... Yeah. How? How would you do this? Other than just randomly moving pieces around to see if they could all fit. Yeah. I don't know. I have no clue on this one. None. So, yeah. I need to stew in my head this one as well. So I think I've hit an impasse here. If I look at my calendar, 1, 2, 3, 4, 5, 6, 7 left. I think for part 11, if I let this run over lunch, I should eventually get an answer. I think. If I don't in over like an hour or two, then that means there's something severely wrong with the way I've interpreted the problem, or at least in how to solve it, or what conditions could eventually arise, or just how many paths you actually have to visit. That's the other thing too, is do you end up hitting many duplicated parts of paths in a solution, and if you already knew that it hit those two, you could just say at that point, I know the answer is true. Because I know that if I know my parent got me to the point where it got me these two, then I don't have to search the rest of it. That may be one possible optimization. Because then the next time you come through it, you'll just say, oh, well, that got me a DAC and a fit. So I don't have to do that again. I don't have to go down that path again. I already know that that gives me what I want. That might be something that I think about it. I'll put in my notes for day 11, part 2. Yeah, does a shape exist within another shape? Yeah, I'm not going to get two problems. Focus on what you were going to type, Jason. One possible optimization is to keep track of a parent node that led to hitting both a DAC and a FFT. That parent node would be the node just before we found one or the other. For example, let's just say we had AAA, BBB, CCC, DAC, FFF, GGG, HHH, FFT, QQQ, SSS, out. Okay, SVR. In this case, we know that hitting CCC gives us a path that we're looking for. So if we have something like this, let's just say we had TTT, FF, no, not FFF, because we don't want that. YYY, ZZZ, CCC. We can stop at CCC and say increment, because we already know that this gives us and increment the count. Because we already know that CCC will hit both DAC and FFT. So as soon as we find one of these, we're going to say for that recursive path that we're following, keep track of that parent. Right? And we can't just say for one DAC or one FFT, because those could be hit from different paths going through different ways to get to an FFT or a DAC. It doesn't matter. What we do know is that as soon as we hit one of them, that parent node that got us to at least the first one, we want to keep track of, because if we get all the way to the end and that was a path that we wanted to have, we want to keep track of that root node, because if we hit it again in our searches, we could immediately increment. We don't have to keep going through the rest of it. I'm going to let this run, but what I might do the next time I do a random code stream is to see, did I actually get a value after like letting it run an hour or two, and if it was correct. And then either way, if I did get that, I might do the optimization, or if I didn't do that, then in the next one I'll put that optimization in, which I think might be an optimization, and then see if that helps the search. So yeah, we'll do that. I can do 7, I believe. I think I got a solution for 7, and we'll see for 11. I think for 9, that one is possible. I just don't know. How do you say that the area that you're looking at is completely within the area of the bounding shape? How do you determine that? Because the shape is quite complicated. And so how do you say that any of those points lie completely within the shape itself? How do you know that you were outside the shape? I'm assuming there is a mathematical solution for that. And that's okay. I mean, part of the thing with Random.Code is to make you go, okay, how do I determine how to solve this? I don't just want to look up, how do I figure out part 2 of day 9? How do I do that? Unless you get so stuck that you're just like, I have no idea where to go with it. But I want to at least just look up first, how do I determine if a shape is within another shape? And see what kind of research I get off of that. So I think I could do 7. I still think I can go back and do 7. I think 11 is doable. And I think 9 is doable with, I mean, all of them are doable, but doable with a little bit of research. 10 and 12, no clue. I know what the problem is and how it's stated. I have no idea how to solve it efficiently. So those might be left as I just never got to them, which is fine. The last year I didn't solve all the problems either. So, oh well. It might be worth trying to look up what the solutions are and then see how to actually do them, but offhand, I just feel bad because like in 2022, I got all 50 without any research. And I felt pretty good about that. But I don't know everything that there is to know in software development. So part of this is a way to solve a problem may require you to know something. And it does require you to know about something to make it solved efficiently. I just lucked out, I think, in 2022 because I was able to do all that. So anyway, that's the plan. I'm going to stop the stream here. And then tomorrow, I plan on doing another random code stream and continuing on with this. I'm also going to be doing some Halo Infinite streams this afternoon. I'm probably going to do one after lunch and then one after dinner. So playing more Halo Infinite, which I'm really enjoying to do. But I'm going to stop the stream here. I want to thank everybody who's been watching, either now or in the future. Please subscribe to the channel. I'd really appreciate it. And hopefully I'll see you in a future stream. But for now, I'm going to end this stream. Thank you all for watching. Take care, and I hope to see you in the future.